We are continuing our work on rational expressions. If I had the fraction 15 over 24, that's going to simplify. Oh, you're here. Nope, you're good. So 15 over 24 simplifies, and here's why it simplifies. 15 is 3 times 5, and 24 is 2 times 2 times 2 times 3. And anytime you take a 3 and divide it by a 3, you get 1. So 3 divided by 3 goes away, and I end up with 5/8. You guys understand that? Okay. What if I had 10 over 15, and I multiplied it by, let's say, 21 over 14? Well, 10 is just 2 times 5, and 15 is just 3 times 5. 21 is 3 times 7, and 14 is 2 times 7. And those are multiplied together, and multiplication is both associative and commutative. So I can mix the top together. I could put them together, put them in order, and it would still be the same fraction. So really, on top I have 2 times 3 times 5 times 7. And on bottom, I have 2 times 3 times 5. Oh, that's not what I meant to do. But they all cancel. So if everything cancels, what's the answer? 1. Okay? Yeah, I really didn't mean to do that, but it works. Okay. What if we had 4 over 21 divided by 6 over 14? Hope I didn't do it again. How do you divide two fractions? You just flip and times it, as Tom likes to say. Which one do you flip? The one that's being divided. Or, sorry, the one doing the dividing. So we flip this upside down. So the first one is 2 times 2 over 3 times 7. And I multiply that by 2 times 7 over 2 times 3. And the 7s cancel, the 2s cancel, and I'm left with 4 over 9. You guys understand that? Well, I could say, so let's say I flip this. Okay, I could figure out what 4 times 14 is, which is 40 plus 16, so 56, over 21 times 6 is 120 plus 6 is 126. And then I could simplify, right? But what is the 56 made up of? It's right here. The factors of the 56 exist before the multiplication takes place. So instead of multiplying and then simplifying, why don't I just simplify? So this turns into 2 times 2 times 2 times 7 over 3 times 7 times 2 times 3. And then I end up simplifying. But that's more work than I need to do. Why don't I just factor and simplify and save the multiplication step? Does that make sense? So, good question. And it turns out, if you have a fraction times a fraction times a fraction, any factor in the numerator can cancel any factor in the denominator. And if one of them is actually a divide, then just flip that one upside down and use the multiplication rules. So, let's take a look at our assignment. So here, we're extending our multiplication to include variables. Are there any numerical factors in the numerator that cancel a numerical factor in the denominator. 14 is really 2 times 7, and then 7 cancels 7. You guys understand that? And then x and x turn x to the third into x to the first. And b squared changes the b to the third into b to the first. So on top, I'm left with 2 times b, which is 4b, over 7's gone, x. That's the fast way to do it. The slow way would be to say the top is 28x squared b to the third over 7x to the third b squared. And then simplifying that. It will still work. It just takes a lot more time to do it that way. Okay. Same thing here, but I cannot, cancel a portion of an addition or a subtraction. Like, I can't knock those x's out. It's like saying, if I had 2 plus 7 over 2 plus 3, can I just cross those out and say the answer is 7 over 3? No, because the actual answer is 9 over 6. Are those the same thing? How about 5? 9 over 5 is different than 7 over 3. So we cannot cancel a portion of an addition or a subtraction. We have to cancel everything or nothing. But we do have a trick. We can factor. So is there any number that those two terms have in common? A 5. So 5 times 3x plus 7, okay? And that's multiplied by, does that have anything in common? 2. And I'm left with x minus 3. Does this have anything in common? 8 times x minus 3. And what about this one? No. So it just stays 3x plus 7. Now, I have transformed it from addition and subtraction into multiplication, and I have to take each set of parentheses as though it's one number. Does anything cancel? This cancels that. This cancels that. Anything else? The 2 turns the 8 into a 4, and my answer is just 5/4. Okay? And then remembering from the last lesson, x is not allowed to be what? What makes this 0? 3. What makes this 0? Negative 7 over 3. Now, that's not part of this problem, but anytime you have a variable in the denominator, you have to remember, ooh, I might end up with answers that don't work. Okay, number 3. Same basic idea, but now we're going to be factoring quadratics. This turns into x minus 3 and x plus 2. And then x plus 1. And on bottom, we get x minus 1. And then I can pull a 3 out of there. 3 times x minus 3. Anything cancel? X minus 3, x minus 3. So, the question is, how does it want the answer listed? And nobody really agrees on this. Should we leave the answer like this? Or should we leave the answer like this? And the thought is it depends on what you want to do with it. Sometimes it makes more sense to leave it in factored form. Sometimes it makes more sense to multiply everything out and then leave it in kind of polynomial form. And I'm not sure what they want, so let's see. And maybe it will take both, I'm not sure. Incorrect. Show me the answer now. Oh, hey, factored form. That makes me happy. Because most of the time we want it in factored form because we're going to use the factored form to draw the graph. And the graph is really easy to draw in factored form. And if it's not in factored form, you have to factor it in order to draw the graph. So, good news. We will keep our answers in this form. Okay. Let's try. Oh, I got it wrong. Dang it. All right, this is a division problem. So I just flipped this upside down. 4bc over 3c squared, or to the third. So the 2 turns the 4 into a 2. These two c's get rid of 2 of the 3 c's. And 9 and 3 turn into a 3 on top. And b cancels b. So on top I have 2 times 3. So 6 over. So on top there was, oh, yeah, let me rewrite that. That was, you guys can't see what I'm doing. Okay, so 9c times 4bc over 2b times 3c to the third. So on top I have c squared. On bottom I have c to the third. So this c and this c cancel 2 of the 3, and I'm left with c to the first. They both. So on top I have c times c, and on bottom I have c times c times c. What's your question? Sorry, somebody else had a question? Yeah. So that division tells you to flip this one upside down. Okay. And the b cancels the b. And the 2 turns the 4 into a 2. And the 3 turns the 9 into a 3. So the only things I have left on the top are a 3 and a 2, which makes 6. And on bottom, everything went away except c to the first, like that. Now again, if you forget that or if you don't understand it, you can just multiply everything together. So you would end up with 36bc squared on top, and then 6bc to the third on bottom, and you can cancel it that way. Okay, but in my opinion, it's easier to cancel it before you put everything together. So now we have things that we need to factor, and there's a division. So the left side would be 2 times x minus 7, and the right over 3. Multiply, and again we have to invert this. So 7 on top, and 6 times x minus 7 on bottom. So the x minus 7's cancel. The 2 goes into 6 3 times. So the final answer is 7 on top and 9 on bottom. Does that make sense? Okay, and then I think this is the last one. So on the left side, we have x plus 2 over, factor that, two numbers that multiply to be negative 3 and add to be 2. So 3 and negative 1. And then we reciprocate this, 3 over x minus 1 and x minus 3. Does anything cancel? Just the x minus 1s. And luckily the people who built this were really smart, and they said leave it in factored form. So on top we have 3 times x plus 2, and on bottom we have x plus 3 and x minus 3. Okay? Now, eventually, we're going to learn how to graph this, or I guess graph this. And they don't look like graphs that you're used to seeing, and a lot of weird things happen that haven't really happened so far in your function graphing experience, but we'll get to there. Okay, 3.2, get to work.